let's look at some more graphs that can be generated. In fact, let's look specifically at conic sections that can be generated using polar coordinates. Here we have a graph, r equals 9 over 5 minus 4 cosine theta. If we plug that into our calculators, we get a graph that looks like this. Looks remarkably like an ellipse. But let's see if we can actually prove that the graph is an ellipse by converting our expression 9 over 5 minus 4 cosine theta into an expression in terms of x's and y's, and see if we can identify the conic section that way. So we're going to start with our equation. R equals 9 over 5 minus 4 cosine theta. And the first thing I'm going to do is deal with that denominator. I'm going to multiply both sides by 5 minus 4 cosine theta. So after doing that, I'm left with 5r minus 4r cosine theta equals to 9. And from here, the next thing I'm going to do is I'm going to use my relationships where r squared equals x squared plus y squared, and r, or x, equals r cosine theta, and y equals r sine theta, to convert my equation. I see that right now I have an r cosine theta, which I can replace with x. So I can put minus 4x here. Now, if r squared equals x squared plus y squared, then r equals the square root of x squared plus y squared. So I can replace this 5r with 5 times the square root of x squared plus y squared. Then I can subtract the 4x, have it equal to 9. And I'm very close. I now have my expression in terms of x's and y's, but it's not anything I recognize. So what I'm going to do is I'm going to perform a little more algebra. Here's 5 square root x squared plus y squared. I'm going to set that equal to 4x plus 9. I'm moving the 4x over to the other side. Now I'm going to square both sides, leaving me with 25 times x squared plus y squared. Now when I square this, I have to FOIL, so 16x squared plus 72x plus 81. I'm going to distribute 25x squared plus 25 y squared equals 16x squared plus 72x plus 81. Now what I'm going to do is I'm going to set this whole expression equal to 0. So I'm going to subtract everything on the right and move it over to the left. So I get 9x squared, 25x squared minus 16, plus 25y squared, plus 72x, or minus 72x, minus 81 equals 0. And here, by looking at this expression, I can identify that this has to be an ellipse by looking at the coefficients on my x squared and y squared terms. Since they both have the same sign and are different values, I've generated an ellipse. How does that work? Well, let's quickly review the general equation for conic sections and how the coefficients on my x squared and y squared terms identify which conic section we're working with. So here's the general expression for conic equations. Ax squared plus by squared plus cx plus dy plus e equals 0. Now, if a is equal to 0 or b is equal to 0, that means I only have one squared term in my expression. And one squared term tells me that I must have a parabola. Now, if I have the same coefficient on my x squared and y squared terms, I can go through the process of completing the square, and that will tell me that I have a circle. If they have the same sign, the x squared and y squared coefficients, but they have different values, that means that our circle has been warped and becomes an ellipse. Now, if they have different signs, if I'm subtracting one from the other, that means that I must have a hyperbola. Now let's figure out how we can identify which of these conic sections we have without going through the entire process of converting our polar equation to a Cartesian equation. Well, here's the standard equation in polar form of a conic section. R equals k over a plus b cosine theta, or r equals k over a plus b sine theta. So if we look at that, we see that it's actually the reciprocal of a Limousin equation. Now, here's the way I figure out those relationships. If I think about the different graphs of our conic sections, I know that my ellipse is a continuous graph. There's no discontinuities when I draw an ellipse. So that would mean that there could be no discontinuities in my polar equation either. And the only way I can have a discontinuity here is if I'm dividing by 0. Divide by 0 would mean that my b value would have to be larger than my a value. Think about that and figure out why that would be true. So if b is greater than a, that would mean that I couldn't have an ellipse. If b is less than a, then there's no way for me to divide by 0, and that would give me an ellipse. If b is larger than a, that would mean that there does exist the possibility of dividing by 0. So then I would have regions of my graph where the graph isn't defined. And that would allow me to have a hyperbola. If b and a are exactly equal to each other, then there would be only one place where the graph is equal to 0, or in other words, we would have a parabola. So let's think about how that relationship between Limousins and cardioids would work. If the Limousin has a loop, that means that my graph, my r value, can go negative. And if r can be less than 0, it can also be equal to 0, which would mean that in our reciprocal, we would be dividing by 0. So therefore, we should have a hyperbola. If the Limousin has no loop, that would mean that r will always be positive. Which means that I will never divide by 0. My graph will be continuous, and I will have an ellipse. Now, if the Limousin is a cardioid, that means that r will be exactly equal to 0, but never negative. which means I will end up with a parabola.